Hello ladies and gentlemen. Today we're going to look at transformations of functions because I know that some students do struggle with this. By the end of this video you'll be able to understand how to transform a graph based on its function and to answer questions involving them. So let's look at some general rules. If this has equation y equals f of x, right? What would the line y equals f of x minus 3 look like? Well, whenever we have a add outside of the function, we're simply going to move it towards that direction. So because it's going minus 3, as you can see, it's going down 3. 1, 2, 3. Here's minus 1, then it's minus 2, then it's minus 3, and so on and so forth. So what we'll do is we'll move this down 3 times. So we're left with, what is it, 5 up? So then that's there. So we're left with a function that looks something like this. Right? And this has equation y equals f of x minus 3. And I think most of you have probably guessed by now that if it's y equals f of x plus 2, we're simply going to make it go up by 2. So it should look something like this. Yeah? What about if it is inside the bracket? So if this is, once again, we're going to do these examples with the same graph. If this is y equals f of x, what would the graph of y equals f of x minus 2 look like? Now you might be thinking, okay, so if this is minus 2, because it's going in minus, we're going to have to put it twice, right? No. This one we're going to do it the other way around. And the reason for that is a bit tricky to explain. If you guys want to, I can explain in a video in the future. But the easiest example I can give is look at a straight line y equals x plus 1, right? So this is, it's a bit bad, but it's fine. If this is y equals x plus 1, right? Y equals x, right? If we were to do y equals x plus 1, we'll get something that looks like this, right? Right? This is y equals x plus 1, isn't it? Because obviously, it's gone up by 1, right? But look carefully. Look what else. It's also gone to the... You've shifted it up, sure. But you've also shifted it to the left by minus 1. So therefore, using that same logic, we're going to shift... I'm going to just make this in green. We're going to shift this parabola to the left, to the right, excuse me, by plus 2. So this is y equals f of x plus 2. Minus 2, minus 2, minus 2, minus 2, minus 2. And, as I've probably given away, if we have something like y equals f of x plus 4, then again it's going to be the same, but we're shifting it to the left by 4, as opposed to the right, which on the surface makes sense, but if you look at it a little bit deeper, it doesn't make a lot of sense to do it. It's always, whenever it's in the bracket, you want to flip it. That's just the long and short of it. Y equals f of x plus 4. Because we've shifted it 1, 2, 3, 4. Okay, what about something like this? Once again, this is y equals f of x, right? What about y equals f of minus x? What's that gonna look like? Well, if we have it inside here, I want you guys to really think of it like this, right? If it's inside the x, inside the bracket, then x is changing, right? So, in order for x to change, we want to reflect it on the y-axis, right? So therefore, our graph will look something like this. Yeah? Sure. So all we've done is we've reflected this on the y-axis. So this is y equals f of minus x. Because guess what? X is changing as a result of being reflected on the y-axis. And it should come as no surprise that if, let's say, this is y equals f of x, then y equals minus f of x is just going to be flipping on the x-axis. So we're flipping it this side because y is changing. Yeah? But let's look at an example. So let's say we have something like this. This graph has equation y equals f of x, right? And we're told the minimum point of this, the maximum point, excuse me, is minus 2, 1, right? So how are we going to find the coordinates of the turning point with equation y equals f of x plus 3? Well, remember what we said. We're shifting it to the... If it's minus, we flip it, so it's going to be plus, right? We're shifting it to the right, 3. So this is minus 2, and we shift it to the right 3. We're plussing 3 here. So what's minus 2 plus 3? It's going to be 1. So the answer is 1, 1. If we're flipping it like this, right? Y equals f of negative x. Remember, it's in the bracket. So therefore, we're going to change x. And the way we change x is we're simply going to flip the sign of our x coordinate. Y stays the same, so we can just say that straight away. But if this is minus 2 and we're flipping the sign, right? What happens? Exactly. It's just going to be 2, isn't it? I'm going to rub this out just to make a bit of space. What if we have to do multiple transformations at once? So in this case, we're told, what is y equals f of negative f of x plus 2? Well, if it's x plus 2, the first thing we're going to do, we're going to have to do these in order. It doesn't matter really which order we do it, but we're going to have to do this in order. So, let's flip it. Let's shift it to the left twice. So it's going to be 1, 2. So here it's at 4, 1, minus 4, 1. And because it's minus f of x, we're going to flip it so it looks something like this. And what do we do with our y coordinate? Remember, y is changing. So we're going to flip the sign. So what we're left with is -4 minus 1. And finally, this one is no different. We start by putting it -1. Remember, this is y, so it's going to actually be shifted -1 down. So here it's -2, And now we're flipping it via the y-axis because x is changing. So we're going to flip the sign. So what are we left with? If this is -20, then our answer is just going to be 20. So now we've just used, all we've done is just use these 4 rules to flip one single coordinate. But what about if we kind of have to remind ourselves of our composite function rules to work out something like this? So figure 1 shows the sketch of an equation. F of x is equal to x plus 3 all squared times x minus 1. And we're told that it crosses through -3 and -9 and 1. So what would y equals f of x plus 2 look like? And what would it meet at the x-axis? Well, because it's going x plus 2, we shift to the left. Yeah? So this one, when we shift it to the left twice, what's it going to be? We shift it once, it's 0. We shift it again, it's going to be -1. Same with this, -3. We shift it once, -4. Shift it again, this is -5. And then our coordinates will look something like, or our cubic will look something like that. Because all we've done is we've shifted everything to the left by 2. Yeah? So now, what is the equation of the curve going to be like? Well, do you guys remember when we did composite functions? We know that f of x is equal to x plus 3 all squared times x minus 1. So therefore, all we're going to do is substitute in x plus 2. So f of x plus 2 is going to be equal to, I'm going to sub it in with red, x plus 2 times, plus, what is it called? Yeah. Plus 3 times x plus 2 minus 1. Yeah? And so what we're left with is, I mean, if you couldn't tell already, it's probably going to be x plus 5 x, all squared, sorry, x plus 1. And that is our final answer. So using your answer to part B to find the coordinates of where the point at which the curve C meets the y-axis. Okay, at the point at which it meets the y-axis, what did we say that x is equal to? X is equal to 0, right? At the y-axis. You agree? So therefore, this equation is simply going to be f of 0 plus 2 is going to be what we have. Sorry, just say f of 0, sure. Is simply going to be zero plus 5 squared times 0 plus 1, which is the same as what's 5 squared? 5 squared is 25 times 1. So we're left with 25. Yeah? So now what we've done is we've just combined our knowledge of composite functions to transform a graph. Thank you guys for watching. I hope this video made a bit of sense to you. If you guys liked it, please subscribe. It means the world to me. If you guys have any further questions or comments, join my Discord server to answer any individual problems that you're having in your studies. If you guys need some one-to-one tutoring, drop me an email and we can organize a time, place, and a quote. Keep on learning, as you have no idea what you're capable of doing.